Okay, so we're continuing to learn function operation. Today we will learn a new one. It's called function composition. Okay, so the notation is f compose g at x. Sometimes write it in this way, f of g of x. So this reads f compose with g at x, or f of g of x. Okay, so how to operate this function? For example, I have a function fx equals to negative 4x plus 1, g of x equals to negative 4x plus 3. Okay, so now I want you to find f compose with g at x, which is f of g of x. Okay, the first step is you want to substitute g of x equals to negative 4x plus 3. So here you want to replace g of x with negative 4x plus 3. So f of negative 4x plus 3. Okay, so after here, this is the function of fx, right? Remember, how do we replace a function with a function? So that means you want to replace the x. Let me use a green one. So that means you want to replace an x with this function. So this has become negative 4. And then whatever inside the parentheses, negative 4x plus 3 at 1. And then we simplify it. We distribute the negative 4 inside. I have positive 6x and then minus 12 at 1. This is equals to 16x minus, oops, sorry. Minus 11. Or the opposite, if I want g compose with f at x. So this is equals to g of f of x. So the first step is you want to look at our inside the parentheses of g of x function. We have fx. So you want to replace fx with negative 4x plus 1 because fx equals to negative 4x plus 1. So I have a g of negative 4x plus 1 in here, okay? And now look at the g of x function. You want to substitute x with this part, whatever inside the parentheses. So I have negative 4 times negative 4x plus 1. And then add 3. You simplify, I have 16x minus 4 plus 3. So this is equals to 16x minus 1. If you take a look, you will realize that, hey, f of g of x is not equals to g of f of x. Okay, one is equals to 16x minus 11, the other is equals to 16x subtract 1. Now, let's try another examples. If I have g of x equals to 3x plus 4, whereas fx equals to x squared plus 3x. And I want you to find f of g of x, or h composed with g at 3. So So let's do the first one. So I have f of g of x. So g of x equals to what? 3x plus 4. So that I have f of 3x plus 4. And then what? Now you look at the fx function because now it's the function about fx. So you need to replace these two x with 3x plus 4. So that I have 3x plus 4 at 3x plus 4. These two parts, it was x and now it's become 3x plus 4. This one is square, cubic. I'm sorry, it's cubic. And then you add 3 times 3x plus 4. So how to simplify the cubic function? So it's equal to, remember the slope, same opposite, always positive. So I have what? Try it by yourself. I'll give you 5 seconds. See if you still remember how to do the cubic function. Okay, so this is equals to what? 3x, 4, and then 3x squared, which is 9x squared, xy, which is 12x, and then 16. 4x squared is 16. The same, which is add opposite and always positive. Okay, and then add, distribute the 3 inside the parenthesis. I have a 9x plus 12. Now, how to do this one? It's tedious, but it's not hard. It's just like a FOIL. You want to multiply every term from the two parentheses. I have 3x times 9x, which is 27x cubed. 3x times negative 12x is minus 136x squared. 3x times 16 is equals to 48x. And now you use positive 4 times 9x squared is equals to 136x squared. And then minus 48x, 4 times 16 equals to 64. And then add 9x at 12. Now you want to combine the like terms. I have 27x cubed, and then let's look at x squared. I have 36x squared and negative 36x squared. This cross cancel. And then I have positive 48x and negative 14ax. Cross cancel. And then I have 9x. And then 64 at 12 equals to 76. Okay, so that's f composed with g at x. So now what about, not h, I'm sorry, this means f. So if now I have f composed with g at 3 means what? Means when x equals to 3, the function equals to what? So I have 27, 3 cubic at 9 times 3 at 76. So 27 times what? 3 to the cubic is 27 at 27 at 76 equals to 832. Okay, so let me recap this. So this is basically is you need to find the composition of the function, where it's in here, and then you substitute x equals to 3 into every x of the composition function. Okay, I know this is not easy, so now let's do another examples. Okay, if I have f of n equals to negative 2n squared minus 4n, and then g of n equals to n plus 2. And then I want you to find f of g of n. Also, I want you to find g composed with f at negative 3. Okay, so now let's find the first one. F of g of n. So g of n equals to what? N plus 2. So that means you want to substitute n plus 2 into the parenthesis. And now, when you look at f of n, that is equals to 2, negative 2 times n plus 2 squared minus 4 times n plus 2. Because you want the n plus 2 will substitute with this n. These two n's, so that I have a 2n plus 2 into that equation. And now we simplify it. So I have negative 2 times n squared plus 4n plus 4 minus 4n subtract 8. You simplify it, you have a negative 2n squared minus 12n subtract 16. So that's f composed with g at n. So what about the other way? G composed with f at n. This is equivalent to g of f of n. So fn equals to what? Fn equals to negative 2n squared minus 4n. Okay. And then g of n equals to what? Is equal to n plus 2. Now I want to substitute negative 2n squared minus 4n with our g of n function, and then I add 2. Now I simplify, I have negative 2n squared minus 4n plus 2. But this is not enough because we want to find out, hey, at negative 3. So now let's do the negative 3. We substitute n equals to negative 3 into the equation. I have negative 2 times negative 3 squared minus 4 times negative 3 at 12. At 2, sorry, not 12. We simplify it, we have negative 3 squared is 9. 9 times negative 2 is negative 18 at 12 at 2. So this is equal to negative 4. Okay, so that's it for the function composition. If you have any questions, feel free to ask me. I'll see you next time.